Hello everyone. In previous lecture we had completed chapter 6 and now we are going to start a new chapter. This is chapter 7 and the name of this chapter is Shear Strength. So in this chapter we are going to study about the details about the shear strength of soil. This is the outline of this chapter. So first is why it is necessary or necessity of studying shear strength of soil, why it is necessary. As we know, soil failures usually occurs in the form of shearing along internal surface within the soil, and so the study of shear strength is necessary to know the detail about the shear strength of soil before construction of any structure. Then the shear strength or introduction of shear strength. Structural strength is primarily a function of shear strength, and the strength of a material is the greatest stress it can sustain. So the safety of any geotechnical structure is dependent on the strength of the soil. If the soil fails, the structure founded on it can collapse. Thus, the shear strength is the capacity of a material to resist both the internal and external forces which slide past each other. Or we can also define as like that: the shear strength of soil is the resistance to deformation by continuous shear displacement of soil particles or on masses upon the action of a shear stress. The failure conditions for a soil may be expressed in terms of limiting shear stress called shear strength or as a function of the principal stresses. And all stability analysis in soil mechanics involve a basic knowledge of the shearing properties and shearing resistance of the soil. So the shear strength is the most difficult to comprehend and one of the most important of the soil characteristics. And basically, the shearing resistance of soil is constituted three components. The first one is the structural resistance to displacement of the soil because of the interlocking of the particles. Then second one is the frictional resistance to translocation between the individual soil particles at their contact points. And the third one is the cohesion or adhesion between the surface of the soil particles. So these are the basic three components of shearing resistance of soil. And the shear strength in cohesion-less soil basically results from intergranular friction alone, while in other types of soils it results from both from internal friction as well as from cohesion. Next is the significance of shear strength. So, engineers must understand the nature of shearing resistance in order to analyze soil stability problems such as bearing capacity of soil, also the slope stability of soil. So, the shear strength of soil is the capacity of soil to resist the internal and external forces which slide past each other. Next, it also the resistance to shearing stresses. Already I have discussed about it. So shear failure occurs when the stresses between the particles are such that they slide or roll past each other. Next is the components of shear strength of soils. It also already I have discussed that soil derives its shear strength from two sources. First is the cohesion between particles. That means cementation between sand grains, electrostatic attraction between clay particles. Second, from the frictional resistance and interlocking between the particles. As shown here, the figure shows the cementation is this and these are the sand or grains. So, these are the basic two components from which the shearing resistance of soil is developed. Next is the factors influencing shear strength of soil. So, the first component is soil composition like mineralogy, grain size and grain size distribution, shape of the particles, pore fluid type and content, ions on grain and in pore fluid. So these are the soil different composition which affect the shear strength of soil. Second is the initial state of the soil. Like state can be described by terms such as loose state of soil, dense state of soil, then over consolidated, normally consolidated, stiff soil, soft soil. So according to their state, it also, shear strength of soil also depend on it. For example, if the soil has more dense or soil is more dense or more compacted, then obviously the shear strength of the soil is more. And on the other hand, if it is loose soil or the amount of void or pores present in the soil is more, then obviously the strength or shear strength of soil is less. Number 3 is the structure. It also plays a major role to determine the shear strength of soil, like the manner in which the particles are packed or distributed. That means they are loosely packed or closely packed. If loosely packed, strength is less. If more compacted or closely packed like this, then obviously its strength is more. Features such as layers, voids, pockets, cementation, etc. are part of this structure. Next term is stresses. So, gravity generates stresses, which is force per unit area in the ground at different points, and a stress on a plane at a given point is viewed in terms of two components. Like first is the normal stress, notation is sigma. It acts normal to the plane and tends to compress soil grains towards each other, due to which volume change occurs. So after applying this normal stress, the volume decreases and it is always applied normal or perpendicular to the plane. Number 2 is the shear stress. This is tau, like this, as shown in the figure. This is the normal stress and this is the shear stress. So it acts tangential to the plane and tends to the slide grains relative to each other. So after applying this shear stress, the particles try to slide each other, due to which distortion and ultimately sliding failure occurs. So that by applying this stress, there is slide failure occurs. Next is the important term, which is Moore-Coulomb failure theory or criteria. This is an important question for you. So, through a point in a loaded soil mass, different planes pass and stress components on each other depends upon the direction of the plane. It can be shown that there exist three typical planes mutually orthogonal to each other, on which the stress is wholly normal and no shear stresses acts. These planes are called the principal planes, and the normal stresses acting on these planes are called as principal stresses. So in order of decreasing magnitude of the normal stress, these planes are called major, intermediate and minor principal planes. And this theory or Moore-Coulomb theory states that a material fails because of a critical combination of normal stress and shear stress, and not from their either maximum normal or shear stress alone. So the failure occurs always due to combination of both the stresses, normal stresses and shear stresses. And a failure theory is required to relate the available strength of the soil as a function of measurable properties and the imposed stress condition, so that it is required or it is necessary to know the failure theory. So the Moore-Coulomb failure criteria is commonly used to describe the shear strength or strength of the soil basically. Its main hypothesis is based on the premise that a combination of normal and shear stresses creates a more critical limiting state that would be found if only the major principal stress or maximum shear stress were to be considered individually. So an element at failure with the principal stresses that caused failure and the resulting normal and shear stresses on the failure plane. So we will assume that a failure plane exists, which is not a bad assumption for soil or rocks and many other materials. So we have to always assume that there is maybe a chances of presence of failure plane, so that we take measure prevention before construction. If we know the principal stresses at failure, we can draw a Mohr circle to represent the state of stress for this particular element. And the Mohr failure hypothesis states that the point of tangency of the Mohr failure envelope with the Mohr circle at failure determines the inclination of the failure plane. So, failure will thus occur at any point in the soil where a critical combination of shear stress and effective normal stress develops. So, shear strength consists of basically of two components. One is the cohesion and another one is the friction. Cohesion and friction, these are the measure points of shear strength. So, higher the value of C and phi, that means cohesion and angle of friction, higher the shear strength of soil. So, this is the envelope. This big picture shows the envelope or Mohr column envelope. So, for this lecture this much. In next lecture again we will continue with this Mohr column failure theory. Thank you.